machholz, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 24 for the week of June 17th, 2020. The related website for this podcast is donmachholz.com. That is spelled DonMachholz.com, 2 H's. What's up in the sky this week? The sun and moon and combination of same make the headlines this week. The summer solstice occurs on June 20th. That is as far north as the sun gets each year. The sun is 23 degrees north of the equator. In the northern hemisphere, the sun rises north of due east, reaches high up in the sky at midday, and sets north of due west. It is above the horizon for more than 12 hours per day, and it gets hot. Days are long, nights are short. In the southern hemisphere, the sun is not above the horizon nearly as long, and it's at a lower angle in the sky. Therefore, it's not as warm in the southern hemisphere these days as it is in the northern hemisphere. For the next 6 months, the sun will be headed south, slowly at first, hitting maximum speed in late September, then settling in at its most southern declination in late December. Happens every year. As our week begins on Wednesday, June 17th, the crescent moon is in our morning sky. During the week, the moon hits the new phase on June 21st at 6:40 Universal Time. By next Tuesday, the crescent moon will be in our evening sky. This is another great week for getting out and seeing some dark skies. Venus and the moon will meet in our morning sky this week. Such a close meeting that the moon will occult Venus, that is, pass in front of it. This occurs at about 8 hours Universal Time on June 19th. The conditions for observations are not very favorable. The moon is a very thin crescent and is 23 degrees from the sun. For North America, the northeastern part of the U.S., might be able to see part of this event at moonrise on the 19th. For the rest of North America, the event will be over by the time they both rise on the 19th. Parts of Greenland and Siberia will be able to see it in their twilight sky. The Atlantic Ocean and parts of Europe, northern and mid-Europe, and Asia, northern and mid-Asia, may be able to see it in the daytime on June 19th. Observations of this daytime event is difficult, but not impossible. It is 23 degrees from the sun, not 5 or 10 degrees. Find Venus first. It is easier to see than the moon. In daylight, the moon will not stand out well. Should make for some interesting images. 2 days after the moon passes in front of Venus, it passes in front of the sun, from occultation to eclipse. This is an annular eclipse, meaning the moon is slightly smaller than normal because it's so far away, and therefore is unable to completely cover the sun as seen from the earth. What is left, as seen at the right time and from the right place, is a ring of sun around the moon in the daytime sky. Your telescope, binoculars, camera, and eyes must have the proper solar filters in order to view this eclipse. That ring of sun is, well, as bright as the sun. Now, for the other type of eclipse, known as the total solar eclipse, the moon is larger and completely covers the sun, so that the corona, the sun's outer atmosphere, is all that is left visible in the daytime sky. This is a real treat that brings multitudes of crowds. This eclipse is not that type of an eclipse, but it will attract crowds. You must be at the right time at the right place. This one is visible from parts of Africa through the India-Pakistan area and parts of China and then into the Philippine Sea and the Pacific Ocean. You say, Don, how can I remember all the places from where this eclipse can be seen? Just memorize the following. It happens in 2020 on the 21st of June, when the sun in the sky gets hidden by the moon. The moon's so far away it can't cover the sun totally, so a ring of fire will be visible locally. There will be no corona visible, at least not in the sky. You need a filter to see this, or else you'll burn your eye. The Congo is where it is first seen by those without myopia, then through South Sudan and into Ethiopia. Mid-morning it visits Yemen and slides by Oman's capital city. Filter it and take a look. I bet it's mighty pretty. Pakistan sees the sun assume the shape of a ring, then into northern India where the eclipse becomes a thing. Tibet is next, then China, sharing this afternoon view, something that everyone can look up to. Taiwan gets to jump on, then the eclipse sinks into the ocean. A day of emotion, a moon in slow motion, proving Newton's 3 laws of motion. Will you be able to see the International Space Station this week? If you live north of 30 degrees north, then it will not be visible this week. Between about 15 and 30 degrees north, you'll see it in your morning sky during the second half of the week. In the equatorial zone, the International Space Station is in your morning sky early in the week. And south of about 20 degrees south, it's in your evening sky all week long. To determine where it will be in your sky, you can go to the website heavens-above.com and enter your location, then click on ISS. This website will also tell you where and when you can see the Starlink satellites, groups of 60 satellites launched by SpaceX for internet communication. I discussed Starlink in podcast number 2 and the problems they cause those who are imaging the night sky. Get out there sometime and watch the Starlink satellites. In the first few days after launch, before they disperse, it looks like a train of lights traveling through the sky. It will be unforgettable. It was discovered several years ago that the planet Mercury, the closest planet to the sun, exhibits a short tail in images taken in sodium light. No one has visually seen it, but it is there, and the imaging proves its existence. To best be able to image it, you need a narrow-band sodium filter, one that sees the light produced by sodium when it is heated from a solid to a gas and sputters off the surface of Mercury. In the past week or so, some amateur astronomers using such a filter have been able to image Mercury's tail in long exposure photographs. I find this to be amazing. When I lived in Northern California, I teamed up with a regional nature center and for nearly 25 years was their go-to astronomy guy. The name of the place is the Placer Nature Center, located near Meadow Vista, California. They reached out to me after one of my comet discoveries was announced in the newspaper, and they asked if I could develop an astronomy program for them. Now, this is something that many of you can do. Science centers, nature centers, local public observatories, and even planetariums can use some help. Many community centers, not specifically science or nature-related community centers, are often willing to make their facilities available for astronomy. This is what I developed for the Placer Nature Center. Several times a year, I offered an astronomy class inside the building, followed by some stargazing outside. Total time was 2 hours. People were asked to sign up in advance, and through the years, the attendance generally varied between about 10 and 20, with extremes of 2 to 45. No matter the time of year, I started the class just before sundown. I signed in the guest and collected money, a requirement of the Nature Center, and we charged something like $5 per person with a discount for a family. Then began my lecture, with demonstrations of the Earth-Moon scale, a walking off of the first 3 planets, which required going outside, and then back inside for a discussion of each of the planets. I handed out star maps and demonstrated how to use them, how to use the binoculars, and a little bit about telescopes. The ages of my students range from 5 through 90, and I really had to keep it moving along to hold everyone's attention. I learned to both educate and entertain. Then, after 1 hour, it was outside to see the sky. By now, the sky was dark enough to pick up the brighter objects, yet it was light enough so that the guests could find their way around. I generally scheduled these classes to be when the moon was in the evening sky, so that was the first object we saw. Then onto any major planets visible, then some bright stars, double stars, clusters, and a galaxy or two. If the International Space Station was making a pass, we would see that too. This observing session would last the whole second hour, but I noticed that many went home after we showed the moon and planets. That's what they wanted to see. These classes were held about 6 times a year, usually on Saturday nights, and if the weather was bad, it was canceled with no reschedule. The next class held 2 months later would simply be a larger class. I added a completely different class that was held once a year. This was a How to Use Your Telescope class, and it lasted 3 hours. The first 2 hours were held indoors. We all set up our telescopes, and anyone without a telescope could use one of mine. Then we went through a workbook I had written describing how a telescope works, eyepieces, finders, and mounts. By the end of 2 hours, everyone was familiar with their telescope and was comfortable using it. The final hour was spent outside in the twilight. Here we would actually find and observe objects. And when we all together found our first object, usually the moon, everyone would look at it through each other's telescope. They gained experience understanding what something looks like through different telescopes. They learned how their telescope compared to other telescopes. So those were the classes that I taught at the Placer Nature Center. In my later years there, the trees around the center grew up a bit and obscured much of the sky. So we had to move telescopes around a bit to show things. I left the area in 2018 and turned the classes over to another astronomer. As said, this is something many of you can do. Find a nature center and partner up. Comet Pan-STARRS 2017 T2 remains in our northern evening sky for the next couple of months, still at about magnitude 9. Its position for each night can be found on Podcast 22 Comet Positions, as are the positions of these next 2 comets. Comet 2020 F3 Neowise is now in the solar vicinity and not visible from Earth until early July, when it will pop into our morning northern sky. It continues to move northward, and a week later, mid-July, it will cross into our evening sky. Comet 2019 U6 Lemon remains more easily visible in the southern hemisphere than in the northern hemisphere as it reaches perihelion, that is its closest point to the sun, on June 18th. It is in the evening sky and will remain there for several months. It makes a close approach as seen from Earth with Comet Pan-STARRS during the first week of August. This week we learn a new constellation. This one has such a distinct shape that many people have looked at it through the ages and said, "What is that?" It is the constellation Corona Borealis, which is Latin for Northern Crown. Right now, it's in your northern evening sky. Its 7 main stars form a semicircle. This constellation, it's small, it has no bright deep sky objects, but it does have some variable stars in it. The constellation Corona Borealis is labeled on podcast 24, map 1. Our binocular object this week is an open cluster in the constellation Ophiuchus. It was observed but not cataloged by both Charles Messier and William Herschel. We do not even find it in the original New General Catalog, but it is in the Index Catalog, so it is referred to as IC 4665. The position of this open cluster is labeled on podcast 24, map 1. It has about 30 stars and is located only 140 light years from us. It occupies an area of about 3/4 of a degree across. Our telescope object this week is a double star Gamma Leo in Leo, also known as Algiba, about 130 light years from us and north of the star Regulus in the constellation Leo. The main star is orange in color, 32 times larger than our Sun, and itself has at least one planet orbiting it. However, you'll not see the planet, too faint and too close to the main star. Gamma Leonis is a double star with the 3.5 magnitude companion, taking 510 years to go around the 2.3 magnitude main star. The separation between the two is 4.2 arcseconds, so a telescope yielding 50 magnification or more should be able to split this star. You have been listening to Looking Up with Don, podcast episode 24 for June 17th, 2020. I'm your host, Don Machholz. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We'll discuss what's going on in the sky, we'll learn a new constellation, and I'll discuss the SOHO solar mission as we prepare for Comet Neowise. Thank you for listening. See the sky this week. I'll see you next week.